Hi everyone. We're going to discuss the polar equation and graph by hand. The first thing we notice, it doesn't look like our normal equation, which is EP over 1 minus or plus something. So what I'm going to do is like we do in our identities, and I'm going to divide each of these terms by secant. So I'm going to write 6 secant of theta divided by secant of theta over 2 times secant of theta over secant of theta minus 1 over secant of theta. When you do that, you're going to get r equals 6 over 2 minus cosine of theta. So basically they just, made a harder problem there. But basically there we go. Now we know this is cosine, so it's going to be, and it's a minus here. So we have 1 minus e cosine of theta. So it's not in proper form because of this 1 here, and this is a 2. So I'm going to further simplify this, pull out a 2. So this will be 1 minus 1/2 cos of theta. Now the 2's will go into 6 3 times. So there's your final equation. 3 over 1 minus 1/2 cosine of theta. Now we can find everything out. My EP equals 3. My E is 1/2, which is less than 1. So this is an ellipse. And I have to find my P. So I have 1/2 times P equals 3. So P clearly is 6, because 1/2 of 6 is 3. Now, I know it's an ellipse. We have cosine here, so the directrix since it's cosine is perpendicular to the polar axis, and it's 6 units. Since this is a minus here, it's a minus, means it's to the left, because remember cosine is left and right, so to the left of the pole, which is the origin, basically. Alright, so let's go ahead and graph it and fill in all the information. So we have basically we can find the vertices by plugging it in. Let me draw the directrix. It's 6 units to the left. Here's your pole. So 1, 2, 3, 4, 5, 6. It's perpendicular to the, oh, why did I do that? Whoops. So basically 1, 2, 3. So it's right here. There's your directrix. Alright, and then to find your points, you're going to plug in everything. So we have, our equation is r equals 3 over 1 minus 1/2 cos of theta. Now, when I plug in my table of values, so I put 0, pi over 2, pi, and 3 pi over 2, I'm going to figure out where I'm at. So at 0, cosine is 1. So we have, and again, you might want to write this down if you need to. So we have 3, because I'm going to erase it. 1 minus 1/2, which is 3 over 1/2, which equals 6. Alright, and then I'm going to go ahead and do pi next. Pi is just going to be plus, because that's going to be -1, so 2 negatives make a positive. So we're going to get 3 over 3/2, which equals 6/3. 6/2, I mean. 6/3, which equals 2. So basically, at 0, we go to 6. So we're going to go out here. 1, 2, 3, 4, 5, 6. So there's a vertex right there. And then at pi, it's at 2. So at pi, I'm going over 2. So 1, 2. So basically this point is 0, actually 6, 0. Remember, we're writing it in polar coordinate form. And then this one is going to be 2, pi. Now to get the vertical part, we're going to use pi over 2 and 3 pi over 2. We know cosine of pi over 2 is 0, so we're just going to get 3 over 1, which is 3, and the same thing's going to happen with pi over 2. So at the pole here, I'm going to go up 3 for the pi over 2. So this is 3, pi over 2. And at 3 pi over 2, which is down here, it's still going to be 3. So it's 3 pi over 2. So there's your vertices. And we're going over by 2, so I'm going to go down 2 and try to kind of make this symmetric. So basically, something like this. Looks like a circle, kind of. Alright, now the only thing we need to know is the center, and we need to find the A first. So the A equals 1/2 this part plus this part. So that's going to be 6 plus 2, and that's equals 4. So the center is at 4, or 6, you have to take your 6 here, minus 4 is 2. So your center is at 6 minus 4, and comma 0, which is at 2. Right there. So this is 2. Now, for our foci, we're going to do subtract. So we have basically, I would just look at it here because this one's easy. There's no fractions. One foci is right here at the pole, so the other foci is going to be 2 over here. So the foci here is going to be, you add 2 to 2 and you get 4, 0. Okay, that's all. Thank you. And I have one more like this, and it's going to be a parabola. Thank you, and have a nice day. Bye-bye.